Good morning, children. So, I am starting the next topic in the stationary waves chapter. Next is vibration of air column in organ pipes. Alright, organ pipes means the musical instrument where the sound is produced by the vibration of air column. So here there are generally two kinds of organ pipe. One is known as open end pipe, another is closed. Now first I will discuss the closed organ pipe. Closed organ pipe, it means that the pipe is closed at one end. Alright, means if I draw the diagram of the pipe, then it looks like this. One end is closed. Alright, this end is closed and this end is open. Alright, now if you consider, suppose this point is at x is equal to 0 and the length of the pipe, let it be L. Clear? Then what will happen? This is the basic of physics of the vibration of air. Just look at the point here. The point here, it can vibrate with maximum amplitude because it is at the open end. So, whatever be the mode of vibration of the air column enclosed within the pipe, here always a antinode will produce. Remember, at the open end, always a antinode will be produced. Why? Because the particle can vibrate with maximum amplitude at that point. And here means this closed end, the particle will not get any chance to vibrate. So always the displacement of the particle will be 0. Means what? A node will be produced always at the closed end. So this is the basic. So, what will be the fundamental mode of vibration? Simplest mode of vibration of any air column is known as the fundamental mode of vibration. So, you see, if you have a node here and antinode here, means the wave is moving like this. Is that clear? Means you see, it is coming. This is, if this is the incident wave, then this is the reflected wave. Alright, clear? So you see, one can write, if you consider that this length is L, as I have mentioned here, so L is equal to AN. And we know, already we studied in the stationary wave, formation of stationary wave, distance between a antinode and a node, consecutive antinode and a node is lambda by 4. So, if you consider the wavelength of the stationary wave or the sound produced is lambda 1, then L is equal to lambda 1 by 4. And this is the fundamental mode of vibration. This is fundamental mode of vibration. Is that clear? You can deal it with analytically also, means writing the equation of the progressive equation of the incident wave as A sine omega t minus kx, and then y2 is equal to minus A sine omega t minus plus kx. You can get, but there is no need to deal it mathematically because all the students may not have maths. That's why I always prefer to teach you in this manner, that without doing the mathematical part, you can handle the situation very nicely like this. So, the first point you have to remember for the vibration of air column in the closed organ pipe is that at the open end always our antinode will be produced, at the closed end always a node will be produced. So the simplest mode of vibration, fundamental mode of vibration will be like this, means half of one loop. What is this? Half of one loop will be produced. And if this is the case, then one can write L is equal to lambda 1 by 4. Means lambda 1 is equal to 4L. Is that clear? So, you know what will be the frequency of the fundamental mode of vibration. You know, frequency is given by speed of sound divided by wavelength. So, what you are getting? You are getting V by 4L. So, this is the fundamental frequency. What is this? This is the fundamental frequency of vibration of air column. Fundamental frequency of vibration. I am writing the short form. V vibrated, it means vibration. Clear? Then, what will be the next mode of vibration? Remember that if you add one loop to a vibration, then you will get the next mode of vibration. So you see what will be the next mode of vibration. If you want to do, means we have to maintain the same length and same width. So here I am drawing it in whiteboard. That's why I am finding the difficulties, but when you will draw the diagram while writing in the exam, you will use ruled notebook, so you will not have any problem. Either you get the width as the 2 or 3 ruled lines and maintain the same width. Alright, in my case it may not be maintained, but what I said that the length and the width of the organ pipe should be drawn same for all mode of vibration, because we are not changing the dimension of the organ pipe. So that you must follow strictly. So as I said that at the closed end one node, open end one antinode will be produced. So how to get after this mode? I said what? Add one loop. Okay. So how you can add one loop? You see, I have added one loop. This is 1/4 loop it was. Now with 1/4 loop, add one more loop, one complete loop. Then you will get the next mode of vibration. So you see, what is the second mode of, this is the second mode of vibration. Second mode of vibration, if it is like this, then you see here there is A and here there is N. So how many pair of AN you are getting? And this is X. And this is L. So you see, one can write L is equal to how many AN? 1, 2, 3. So you can write it as 3AN. Means AN it will be now lambda 2 by 4. Because from this one it is clear, here the wavelength is longer. But here wavelength is becoming shorter. That's why you cannot use lambda 1, lambda 2. So, and this is also the second mode of vibration. So you see, what are you getting? Lambda 2 is equal to 4L by 3. Clear? So, what will be the next frequency for the vibration of air column within the organ pipe? N2 will be V by lambda 2. So, V by lambda 2, when you are substituting, you are getting 3V by 4L. So, you see, V by 4L is N1. So, you are getting 3N1. So you see, you are getting the third harmonic. Why harmonic? Because the concept of harmonic starting from 8th standard you are learning. So I hope you can remember that. So try to remember what is harmonics. If the frequency of any overtone, it is integral multiple of the fundamental frequency, the lowest frequency, then that is known as the harmonic. So here you see odd harmonics are produced. What I have got? 3N1. Is that clear? So next is, what will be the next mode of vibration? So now next one will be, what is the third mode of vibration? Third mode of vibration. So once again, what I have to do? Now it is 1.5 loop. So what will be the next one? I have to add one more loop. Means it will be 2 closed loop and 1 half loop. So you can just draw the diagram this way, that 2 closed loop and 1 half loop. So you see, this is 2 closed loop and 1 half loop. So here again at the closed end you have got node, at the open end you have got antinode. This is X is equal to 0, X is equal to L. So here there is antinode, node, antinode, node. Alright. So what you can write in this case? L is equal to how many pair of AN? 1, 2, 3, 4, 5. So it will be 5 AN. Means it will be 5 lambda 3 by 4. Because 1 AN is lambda by 4. Why lambda 3 I have written? Because it is third mode of vibration. So what are you getting then? Lambda 3 is equal to 4L by 5. Alright, 4L by 5. So what will be the frequency for the third mode of vibration? It will be speed by wavelength V by lambda 3. So if you substitute, you are getting 5V by 4L. Again, V by 4L is equal to the fundamental frequency N1. So what you are getting? N3 is equal to 5N1. So what is the result you have got? N3 is 5V by 4L equal to 5N1. Is that clear? So you see, the second mode of vibration is the third harmonic. Then frequency of the third mode of vibration is the fifth harmonic we have got. So if we do the next one, although if the derivation comes in exam, then till the third mode of vibration you must show. Okay, no need to show the fourth one. So here I am just showing you so that you can understand it better way. So what will be in the fourth mode of vibration? One more loop I have to add. Means what? How many loop will be there? 3½ loop. So let us draw 3½ loop. 1, then 2, then 3 and then half. So if I complete it, it will look like this. Is that clear? So you see here x is equal to 0, x is equal to L, and if I put the positions of node and antinode, these are the nodes and antinodes produced. Alright, always at the open end one antinode and at the closed end one node. So you see one can write L is equal to how many pair of AN? 1, 2, 3, 4, 5, 6, 7. So you are getting 7 AN. Means it will be 7 lambda 4 by 4. Because AN is lambda 4 by 4. As it is fourth mode of vibration, so I have written lambda 4. Is that clear? So you see what are you getting? Lambda 4 is equal to 4L by 7. So what is the frequency for the fourth mode of vibration? You are getting it V by lambda 4. So it is coming 7V by 4L. Means what? N4 is equal to 7V by 4L means 7N1. So what is the result we have got from this discussion? That in the vibration of air column within closed organ pipe, always odd harmonics are produced. Okay, so let us write down the result of the discussion. This discussion you must practice the way I have written and drawn the diagram. Exactly in the same manner you must practice the derivation, because the derivation is important for your exam. So what is the result of the previous discussion? That in closed end organ pipe, always odd harmonics are produced. So the question, probable question from this discussion is that show that in closed end organ pipe only odd harmonics are produced. Then what you have to do? You have to show the formation of the different mode of vibration starting from the fundamental till the third mode of vibration. Fourth one you may not do. And what is the ratio of the frequencies then in the sound produced by closed end organ pipe? It is 1:3:5 and so on. Is that clear? Then next is coming open end organ pipe. Vibration of air column in open end organ pipes. So, open end organ pipe, it means that both the ends are open. Alright. So, if you consider the concept of vibration of the particles of the medium, at the open end, always antinode will be produced. So, if you consider that the vibration of air column in open end organ pipe, then always you have to remember that at the open end always antinode will be produced. So what will be the simplest mode of vibration or fundamental mode of vibration? So fundamental mode means between two antinode we may have one node. isn't it? That is the simplest mode. So you see how the wave will be, how the wave will be produced. The wave will be produced like this. Is that clear? So one can write L is equal to 2an, isn't it? How many an are there? 2an. So you can write an means lambda by 4. So as it is the first mode, so I have written lambda 1 by 4. So you are getting lambda 1 by 2. So what will be the frequency of the fundamental mode of vibration? It is V by 2L. So this is the point you have to remember. I hope you can remember. In contrast with this, the fundamental frequency of the vibration of air column in closed end pipe, it was V by 4L. But for open end, what we have got? V by 2L. Then what is the second mode of vibration? Second mode of vibration means, as I said already, that if you add one more loop, then with any mode, then you can get the next mode of vibration. So already here, half of the loop, but open both sides. So in between, there will be one complete loop. So how you can draw the diagram? That half loop, then one complete loop, and then again half loop. So half loop, one complete loop, and half loop. So you are getting here A, N, and A. So what you can write here? This is x is equal to 0 and x is equal to L. So you are getting L is equal to how many N? 1, 2, 3, 4. So it is 4 AN. Means it will be 4 lambda 2 by 4 means lambda 2. So what will be the second mode of vibration? V by lambda 2. So V by lambda 2 means one can write it like this. Lambda 2 is equal to L. So you can write down that V by L. Now you see what I have done. I have multiplied 2. Why I have done? Because V by 2L is equal to N1. So what we have got? N2 is equal to 2N1. So this is the relation you have to remember, that N2 is equal to V by L equal to 2N1. So you see in the previous case we have got the second mode of vibration, the third harmonic, odd harmonic. But here you see we have got the second harmonic, even harmonic we have got. Then next is, next in the third mode of vibration, if I add one more loop, so what it will be? Half loop, then two closed loop, then one half loop. So you can draw the diagram like this: half loop, then one closed loop, another closed loop, then another half loop. So again you complete the diagram: half loop, one complete loop, one complete loop, another half loop. So here antinode and here antinode. So if you just show the positions of node and antinode, the diagram will be like this. So again this is x is equal to 0, this is x is equal to L. So one can write L is equal to how many AN? 1, 2, 3, 4, 5, 6. So you can write it is 6 AN. Means 6 lambda 3 by 4. So if you cancel, you will get 3 lambda 3 by 2. So lambda 3 is equal to 2L by 3. Okay, this is 3. Lambda 3 is equal to 2L by 3. So you see what is the frequency for the third mode of vibration? V by lambda 3 means you are getting it as 3V by 2L. Means N3 is equal to 3V by 2L. V by 2L is N1. So 3N1. So what is the fantastic thing we are getting from this discussion? That when sound is produced by the vibration of air column in open-end organ pipe, then both the even and odd harmonics are present. In case of closed-end organ pipe, what we got? We got that only odd harmonics are present. But in this case, what you have got? That both even and odd harmonics are present. So you see, if I summarize now the previous discussion, in open-end organ pipe, both even and odd harmonics are produced. And what is the ratio of the different ratios of the frequencies of different mode of vibration? N1 is to N2, N3, 1 is to 2 is to 3, so on. Is that clear? So if the question comes that differentiate between the sound produced in closed-end organ pipe and open-end organ pipe, I am not writing on the board, I am just verbally saying, it is your duty to note it down. So write down what are the differences between the sound produced in closed-end organ pipe and open-end organ pipe. Then first point of difference you can write that in closed-end organ pipe, fundamental frequency is given by V by 4L. Whereas in open-end pipe, fundamental frequency is given by V by 2L. Then what is the second point of difference? In closed-end pipe, only odd harmonics are produced, and in open-end pipe, both odd and even harmonics are produced. Then third point of difference, you can write N1 is to N2 is to N3 is equal to 1 is to 3 is to 5, so on for closed-end pipe. And for open-end pipe, you can write that it is 1 is to 2 is to 3. So you can write 3 points of differences between the sound produced by open and closed-end organ pipe. Now next is coming the concept of end correction. Now while discussing the sound produced by the vibration of air column in the organ pipe, I hope you can remember I drawn the antinote, position of the antinote exactly at the end. Means if this is the end, then I drawn it here. But actually what happens? Actually it happens that the antinote is produced slightly outside the open end. Means not here. It is slightly outside the open end. So the distance between the exact position of the antinote and the open end, this is end correction and denoted by E. And end correction is equal to 0.6 R, where R is the radius of the pipe. So if you apply end correction, then what will be the fundamental frequency for the vibration in closed-end pipe? Instead of V by 4L, just look at the diagram. If this is N, so AN is equal to L plus C. So it will become 4 into L plus C. So this is the relation for fundamental frequency considering the end correction. Then next is coming open-end pipe. So open-end pipe, what will happen? Antinote will be slightly outside. In this case also, to the right side also, to the left side also. So you see, if you consider that exactly it is N, so you see 2AN is equal to L plus 2E. So what will be the frequency of the fundamental mode of vibration? It will be V by not 2L, 2 into L plus 2E, because L plus 2E is the distance between the two antinodes produced. So this is the concept of end correction, and applying the end correction, these two are the modified relation for the fundamental frequency of vibration for closed-end pipe as well as open-end pipe. So from this part, if you have difficulty in solving the numericals, then you may get option in exam on the theory and numerical part, but please do kindly practice the derivations of all formation of stationary wave as well as sound produced by closed-end organ pipe. Means show that odd harmonics are produced in closed-end pipe, and show that both odd and even harmonics are produced in case of vibration of air column in open-end pipe. That's all from this chapter. Thank you, children.